Okay, so sometimes you might have the effects of changing dimensions. So this might mean you have a scale factor of k. All right, so when you have your scale factor k and your dimensions are multiplied by k, your surface area becomes larger by k squared, and the volume is k cubed times the original volume. So when we're looking at our surface area examples, we're actually going to be looking at k squared. So if the dimensions of a figure are doubled, how many times larger will your surface area be? So if your dimensions are doubled, that means that k, your scale factor, is 2. So if that's our scale factor, to get to the surface area, which is k squared, we would have to square the 2, so it's 4. So how many times larger will your surface area be? It will be 4 times larger. Looking at number 2, the surface area of a figure is 62 centimeters cubed. If the dimensions are multiplied by 5, what will be the surface area of your new figure? So my k is going to be equal to 5. Right there. Your surface area of figure is 62. So for our k squared is going to be 25. So that means our new surface area will be 62 times 25, which means our new surface area is going to be 1,550 centimeters squared. We took our original surface area and we multiplied it by our k squared. Number 3, the surface area of a figure is 736 inches squared. If the dimensions are multiplied by 1/4, what will be the surface area of your new figure? So k is equal to 1/4. We're still talking about surface area, so we do k squared. So we would square that, and you would get that your new scale factor, your k squared, is 1/16. So you take your original 736 and you multiply it by 1/16. You get that your new surface area is equal to 46 inches squared. Looking at number 4, cone A is similar to cone B. If cone A has a surface area of 1,422 kilometers squared and cone B has a surface area of 148 kilometers squared, how many times larger is cone A than cone B? So it's A to B. So cone A is 1,422. Cone B is 158. So when we divide them, we get that it's 9 for the surface area. If that's our surface area and they want to know how many times larger is cone A than cone B, you have to go from k squared to k. So to do that, you have to take the square root. So taking the square root of 9, we get that it is 3 times larger. So that's for surface area. If we look at the bottom, we're going to be doing volume. So you need to remember that that is k cubed. So when we look at number 5, if the dimensions of a figure are multiplied by 4, how many times larger will the volume be? So if your k is equal to 4 and you're looking for k cubed, 4 times 4 times 4 is going to be 64. So it's 64 times larger. Number 6, the volume of a figure is 110.5 feet cubed. If the dimensions are doubled, what will be the volume of the new figure? The volume of a figure is 110. If your dimensions are doubled, so k is going to be equal to 2, so k cubed is going to be 2 times 2 times 2, which is going to be 8. So if your original is 110.5, you have to multiply that by 8 to get that your new volume is going to be 884 feet cubed. Number 7. So these are the same types of problems as we just did 1 through 4, but now we're looking at volume. So you're looking at cubing things instead of squaring things. The volume of a figure is 972 meters cubed. If the dimensions are multiplied by 2/3, what will be the volume of the new figure? So your k is 2/3. So if you cube that, you get that k cubed is equal to 8 over 27. My original was 972, and I have to multiply that by 8 over 27. So you get that your volume, 288 meters cubed. Number 8, solid A is similar to solid B if the volume of solid A is 21 and the volume of solid B is 4,536 inches cubed. How many times smaller is solid A than solid B? So take your bigger, 4,536, divide it by your smaller, which is 21. So the volume at this is 216 times. You have to take your cubed root of that to figure out how many times smaller it is. So the cubed root is going to be 6. So it's 6 times smaller. So if we turn to the back, before we've been talking about changing all the dimensions, but now let's look what happens if you only change one dimension. So changing only one dimension means that the figures are no longer, so not similar. Therefore, we need another strategy. Because remember, if you're changing just one side, you're not changing the whole thing. In this situation, choose test values. Calculate both the old and the new surface area or volume, then compare your answers. All right, so let's look. Number 9, how many times larger is the volume of a cylinder if the height is doubled? So it's important to remember your volume of a cylinder is pi r squared times h. So let's look at our first example. We want to choose test values and then compare our answers. So if the original, let's just start with ones. Your radius is equal to 1 and your height is equal to 1. You find your volume. Volume is equal to pi times 1 squared times 1. So the volume is going to be 1 pi. So that's the original. If we take our second one and we double it, we want to just double the height, right? Because it says height is doubled. So your r is still equal to 1, but now your height is equal to 2. Because if you double 1, that means it's 2. Volume is equal to pi times r squared times your height. So this means that my volume now is equal to 2 pi. So if we take our bigger and we divide it by the smaller, because it wants to know how many times larger is the volume of a cylinder. If you do 2 pi divided by pi, the pi's cancel out, so you're left with 2. It's 2 times larger. Number 10, how many times larger is the volume of a square pyramid if the base edge is tripled? So your volume for a square pyramid is going to be 1/3 big B times h. Big B for a square pyramid means that it's going to be side squared. So if we look for the first one, if my side is equal to 1 and my height is equal to 1, and we substitute that in, volume is equal to 1/3 times 1 squared times 1. You get that your volume is 1/3. So if we do our second one, where now the base edge is tripled. So that means my side is tripled. So triple of 1 means that my side is 3. My height is still 1. Volume is equal to 1/3. Now your S is for big B. So make sure you recognize that instead of big B being subbed in, I'm subbing in S squared. That's what I did right here. It's going to be 3 squared times 1. You get that your volume, that'd be 9 over 3 reduces to 3, is going to be 3. So now when you divide 3, and don't let this throw you off, 3 divided by 1/3. Right? If you want to watch how you do this, 3 over 1, because I'm putting this over a fraction, divided by a number with a fraction. You have to flip the fraction and multiply. That's how it works. Or put it in the calculator. 3 times 3 means that it is 9 times larger. I know that this part is what is going to blow your mind. It's just fractions. Looking at number 11. How many times smaller is the surface area of a sphere if the radius is multiplied by 1/2? So your surface area of a sphere is equal to 4 pi r squared. So for my first one, I'm going to say that my radius, because now it's being multiplied by 1/2, I'm going to say that my radius is equal to 2 for my first one. That's my test value. So surface area is equal to 4 pi times 2 squared. The squared only applies to the 2. You multiply that out, you get that it is 16 pi. So now I'm multiplying my original radius, 2, by 1/2. 2 times 1/2 means that my new radius is 1, because we did 2 times 1/2. I got 1. So you plug that in for your surface area. It's 4 pi times 1 squared. So now your new surface area is going to be 4 pi. So when you divide that, 16 pi divided by 4 pi, the pi's cancel out. 16 divided by 4 is 4. So how many times smaller? It's 4 times smaller. Now I'm going to keep doing a couple more examples because they're different shapes. And I want to make sure you understand that it doesn't matter what shape it is as long as you have the formula. So if we look at number 12, how many times smaller is the surface area of a cube if the side length is multiplied by 1/4? So your surface area of a cube is equal to 2 length times width plus 2 times length times height plus 2 times WH. So because it's 1/4, or because I know I will have to multiply it by 1/4, I'm going to pick 4. It's a cube. All the sides are the same. So length is 4, width is 4, height is 4. It's a cube. They're all the same. So your surface area is equal to 2 times 4 times 4 plus 2 times 4 times 4 plus 2 times 4 times 4. So my surface area is equal to, for the first one, sorry, put the number, is equal to 96. Now when I multiply my sides by 1/4, I get that my length is equal to 1, my width is equal to 1, and my height is equal to 1. When I substitute those in, surface area is equal to 2 times 1 times 1 plus 2 times 1 times 1 plus 2 times 1 times 1. You get that your surface area is 6. So how much bigger, or smaller, sorry, smaller, 96 divided by 6 is going to be 16. So your answer is 16 times smaller. Now you can't say we didn't do enough examples. Let's do our last one. How many times larger is the volume of a cone if the radius is multiplied by 6? Your volume of a cone is 1/3 pi r squared h. So for the first one, now it's being multiplied by a whole number, so I'm just going to say my radius is 1, my height is 1. You substitute that in. Oh, I needed a 1/3. 1/3 times pi times 1 squared times 1. 1/3 times 1 times 1 is just 1/3, so it's 1/3 pi. If I do the second one, and my radius is multiplied by 6, so 6 times 1 means that my new radius is 6. My height stays as 1, so volume is equal to 1/3 times pi times it's r squared, so that's 6 squared times 1. Put that in your calculator. 6 squared is 36. 36 over 3 reduces to 12. 12 times 1, so you end up with 12 pi. So it wants to know how much larger is it. So it's going to be another fraction. I know y'all are going to love it. 12 pi divided by 1/3 pi means that my pi's cancel out. I get 12 over 1 is going to be multiplied by 3 over 1. When you divide by a fraction, you have to flip it and multiply. So 12 times 3 becomes 36. So it is 36 times larger. Fun.